Hi folks, here is another problem involving the acceleration of gravity. If you are feeling confident, give this a try and then fast forward through the video afterwards and see how you did. A basketball referee tosses the ball straight up for the starting tip-off. At what velocity must a basketball player leave the ground to rise the 1.25 meters above the floor in an attempt to get the ball? So here's what's going on. I have a basketball player. And this player, will give him some gym shorts and some hair so he looks like he's having a good day on the court. And he wants to get the ball. Now, in order to do that, he has to jump 1.25 meters above the ground. The question is, at what velocity must the player leave the ground to rise that 1.25 meters? Well, his original velocity is what we're curious about. He's going to have now basketball players, it's pretty cool. When they make a great jump shot, ballet dancers do the same thing. When they make great jumps, at the very, very tippy top of their jump, their velocity actually goes to zero because gravity is slowing them. Gravity is making them go from their original velocity, and they go slower and slower and slower until they stop before they fall back down again. So in this case, gravity is slowing the basketball player at negative 9.8 meters per second squared. And the 1.25 meters, that's my displacement. So how am I going to do this? If I look at my variables right here, I look at my equations. Which one am I going to choose? Well, I'm going to choose VF squared is VO squared plus 2AX. And I'm looking for original velocity. So to get original velocity alone, I'm going to subtract 2AX from this side and subtract 2AX from that side. So I'm going to end up with final velocity squared minus 2AX equals original velocity squared. And I want original velocity all by itself, so I'm going to take the square root of this side and the square root of that side. And I'm going to put my thing I'm solving for on the left because that's convention. Final velocity squared minus 2AX. So let's put our numbers in and see what we get. Original velocity is going to be my final velocity, which is a 0, minus 2 times a negative 9.8 because it's slowing. And how far is this player going to travel? He's going to travel in a positive direction. In this problem, I'm calling up positive and down negative because I've got acceleration of gravity downward and I've got somebody moving upward. When you have motion in two directions or things happening in two directions, one must be up positive and one must be down negative. So the displacement is a positive 1.25 meters, and I'm going to pick up my calculator. So the square root of, and I'm going to do this in a couple steps because I want to show you something, 2 times 9.8 times 1.25. Under my square root, I'm going to end up with 24.5 meters times meters, meters squared, divided by second squared. And when I take the square root of that, my original velocity is going to be a positive number, as this negative and that negative cancel. It's going to be a positive 4.95 meters per second, because the square root of meters squared and second squared is meters per second. And that is the original speed that my basketball player must leave the ground to get that ball. All right? I hope that was good for you. We'll see you next time. Bye.